Remember, the probability of x given y can be found as our joint probability mass function gives us the probability of x and y, and our marginal probability mass function gives us the probability of x. So we can find conditional probabilities given a joint distribution. So let's go ahead and take a joint distribution and find the probability that x is greater than or equal to 2, given that y is equal to 0. And so we have the compound probability that x is greater than or equal to 2 and y is equal to 0. So that's x equals 2 and y equals 0, and x equals 3, y equals 0. And so that will be meanwhile, the probability that y is 0, so x could be 1, 2, or 3, and substituting in those values to our formula gives us the conditional probability. Now, it's useful to check the contents. And remember, every time you find a conditional probability, the compound probability, that's the numerator, should be one of the components that make up the unconditional probability that forms the denominator. So if we look at our probability that y equals 0, we see that the compound probability is 2 of the components. Now we can also consider other possibilities. Let's find the probability that x equals 1, given that the sum of x and y is 2. So the probability that x equals 1 and also the sum of x and y is 2, well, the only way for that to happen is that y also has to be 1. And so that probability is next, the probability that the sum of x and y is 2. Well, we'll find all the cases which will make that happen, and those will be, and so our probability is, and so we can find that conditional probability. Or if we don't have a table, but we actually have a formula, we can do essentially the same thing. So let's find the conditional probability that y is 0, given that x plus y is less than or equal to 1. So the compound probability that y is 0 and the sum is less than or equal to 1, well, that's going to be when y is 0 and x could be, and so we find meanwhile, the probability that the sum x plus y is less than or equal to 1, that will occur in the cases, and so that probability is, and so our conditional probability will be, and again, it's worth verifying that our compound probability includes some of the things in our denominator probability.